So thanks everybody for coming. If this is your first time here, I invite everyone to join up with Lansing Codes. That's kind of our home base of operations for several of the Lansing area meetups. And you can find us at lansing.codes. You'll see a calendar of upcoming events. And you'll also have a link there where you can join our Slack community. And that's a great opportunity for you to come up with ideas, share. You can find me on there as just Brendan, and you can give me ideas if there's something that you want to present or if there's something that you want to have presented to you. I'm open to all sorts of ideas. And yeah, I really appreciate Russ offering to speak tonight. I've had the opportunity to work with Russ. I've also known him through the Lansing tech community for years now. And I'm really excited to see what he has to show us about serverless and specifically around the AWS world. So go ahead, Russ.
All right. So for starters, I'll just do a really quick demo. I'm in master, and I'm going to do an SLS help. So you can see the options. And to install this, you can Google how to install it, but it's basically a node module that you globally install. So to deploy it, you just do Sls Deploy. SLS is an abbreviation for serverless. Now, this is actually how we use serverless at my employer, which is MIHIN, Michigan Health Information Network. We use it at the command line in WSL, and that means you don't have to use their serverless site where you can do CI/CD. Like GitHub can point to it as a hook and kick off your deployments and things, but I don't see much point in that. Just because you can build your own CI/CD in Jenkins or something, or use it like this, which is currently what we do. We don't even have Jenkins set up. Part of it's for security because, we've got people on our team who don't trust storing credentials in Jenkins, but we'll probably get there eventually. And by the way, this is working using my AWS credentials, which I've already set up and configured. So it just picks those up and uses them. So this is what it's deploying. This is the main serverless file. You can get like a boilerplate just by doing serverless init. So you give your project a name. It's just a name. Under provider, you've got various required fields. Not that one, but stage is required. And you can default it to dev, but generally we would do this, or not that, actually. I'll show you in the next iteration. I've got 2 branches in this repo, and I've used stage as my option, which you type SLS deploy stage equals dev or test or whatever, and then that becomes your option stage, and that's you use stage for your environment basically. Now, by environment I mean your like dev or test or prod. I don't mean environment variables, which is actually what this section is your environment variables. So all of my Lambdas are going to get a environment variable called stage, set to the stage. And then you can have as many environment variables as you want, of course. Like service, that's just this guy here. And I'm demoing where you can set up all your IAM roles here. So here I'm basically giving my Lambda the ability to execute itself. Or no, sorry. and it doesn't count against my 32 kilobytes of JSON data that I get to work with. And this, what is that called again? JSON path. So it uses JSON path to specify, and that's like your root right there.
Okay, so just regular selectors.
Right. Okay, here they're giving us an example where, let's see, result path $. No, I don't. Oh, task result. I see. Okay, that's a little confusing to me, but it's study it on your own, and you got to play with it because, like I said, even though I work with it, I always have to Google what result path versus output path, and then there's input path too. Sorry, I don't have a quick, concise summary of that, but if we read this, we could figure it out. Any other questions?
So you said the 32K, that's a hard limit on what can be in the output, input, passing between steps?
That's my understanding, yeah.
Okay. That's
what I was told by a member of my team, which he should know. He's run into it before.
Yeah, but you were saying that there's really not a noticeable cost increase when you go from just one function being triggered by one event and then creating another event that then triggers another thing, versus using the step functions. You're saying that you really don't see a difference in cost.
I see. If you have step functions in the mix versus, say, like one Lambda calling another Lambda, which calls another Lambda, or
kind of, yeah. I mean, and the reason I ask is because it's been a little while, but I'd been messing with the Azure functions, and there's the Azure durable functions that isn't quite at the same, at least not at the time, it wasn't like the same level of priority as the Azure step function or the AWS step functions, but the durable functions, it was just a library that kind of did some clever things with storage. And because of that, it basically stored the state of things, after every single call. So every single, equivalent of a step, you would have storage, storing that state. And, I remember playing with one function that I was using, or set of functions, to run some Cypress tests. Switching to the durable functions, it took me up to the, comparatively ridiculous cost of $2.50 a month versus when I just had HTTP triggers going between the different steps. It was 9 cents a month. So it was, significantly more, and it was all based on the IO cost.
Yeah, I think that's how they charge you, actually, is by transition to the next state, like from there to there. So there you go. Per state transition. It's not bad. Per 1,000. Okay. So 2.5 cents per 1,000. I suppose I could add up.
Well, I wonder if that's approximately what it would cost for the compute time of basically running your own, like you'd basically be running a giant software switch if you wanted to emulate that yourself in Lambda. That looks approximately to be like, this is what they'd bill you for the compute time.
Right. Plus, you can always do the free stuff. I mean, if you can fit within it. Go ahead. Can I talk?
Yeah, the other thing that, I hear a lot of people complain about, with serverless is, the cold start time, which would matter if you had something that was customer facing or whatever. Do you find that to be something that, you actually encounter as a problem, or do you work around that other ways?
So if I modify this and save it, okay, and then the first time I run it, that only took like, 110 milliseconds, right? And it ran for 1 millisecond. So that's basically 100 milliseconds is my cold start time. It's not terrible. It might be worse for bigger things, but maybe not even. I don't know. So no, we have not noticed a problem with that. But Fargate tasks, yes, those take forever to start. I kind of miss working with Kubernetes for that reason. It's just Fargate's slow. So the output of red or blue, you get to see the output of what your Lambda returned. So that's very useful. But with ECS, you don't get that. What you have to do then is you write it to Dynamo and then run a Lambda to read it. Or there is in step functions, you can read Dynamo directly or write to it, but it's personally more practical to just run a Lambda that reads it. I don't know if I could find that quick. Yeah, I'm not going to be able to quickly find the syntax for that, but
does that actually then also cause you to have to write more ACLs or the IAM roles to support that, whereas natively you would have been able to see the Lambda output?
Well, let's see. If you are, so the step function seems to automatically. I'm trying to think if we granted. Yeah, okay. We must have an IAM section in our. I'm just trying to remember it, but yeah, we have an IAM section in our serverless YAML that creates a role that our Lambdas use, but we also give that access to the step function itself. So basically all of these things have access to each other. We have like a section for Lambdas so that the step function can execute the Lambdas. And if it can execute the Lambdas, it gets to receive the response as well, the return. So I'm returning the color, and we saw that response in the step function execution right here.
Thank you.
Mm-hmm. But yeah, you would lose that if you run an ECS task. You gain, the ability to run a long task, beyond 15 minutes. You can have, more storage and a lot more RAM. But you lose this. So, like I said, we tend to just, when that's done. One thing we do get as an output from an ECS task is the exit code, 0 or something else, and yeah, you can capture that. And then let's see, step functions has the ability to sort of like a catch so that certain certain failures can go different directions in your you could have this be a let's see here, at the end of your task you can have, like, at the end of a Lambda task, for instance, you could have a section that catches your error. I think it's just like error, and then if it's this, then the next step, or what do they call these, task. Then the next task is this versus the next task is something else. So that way you get to, like, depending on your error, go a different direction.
with your errors, is there any sort of a count you can do? So you could have like a maximum number of retries?
That's a good question. With Lambda, I think, okay, let's find that documentation. I'm just going to Google it because the bottom line is you can have it retry so many times. Like if you're, excuse my Googling if it doesn't work out, but I think I found it. Retry, there it is. So examples using retry and, okay, here we go. There's retry. Maybe only if the error equals handler error, then it'll retry, I guess. For 2 times. And then there's a states.all that can just handle any error. Let's see. And fallback. Not sure what that is. Oh, that's just another state. It's just showing you that you're going to this state. Notice they use a past state just to have a placeholder. If it's this error, go to fallback. And then there's also timeout. Like if your Lambda times out. So yeah, they give you quite a bit of flexibility. But yeah, you might not get all of this. Of course, you don't get all of this with, say, Azure or another. You'd have to use Azure's things. I mean, you can use serverless with. I just don't want to confuse people's minds with step functions versus serverless. We've talked a lot about step functions, but that's just an AWS thing that you can deploy with serverless. But yeah, serverless can deploy to Knative or AWS or even Alibaba's thing. Oh, here's another thing too. I'll show you quick. If your whole step function fails because I don't know, like you have a bug in your flow or in your logic, or like often you'll run into where your let's see, you'll use like an input path that doesn't exist in the payload that came to it, so it'll just exit out. So this is sort of a catch for your whole step function. You can say execute this Lambda if it failed or timed out, and we use that to like email our own team if it fails, because we've kind of made it a rule that don't expect a failure. Write the code so that it never fails. So if it does fail, we know there's something was wrong. A real problem. Because that Lambda just emails us. But yeah, I don't want to keep everybody if they're getting bored of this. So you guys tell me. Hold on. There it goes. So what do you guys think?
This was useful.
Good. Good. Thanks for coming. Or staying at home.
Yeah, thanks for sharing, Russ. Really appreciate it. It was some cool stuff. I know people have brought up the serverless framework in particular and during past discussions. So it's kind of cool to see how that lays things out and hear some of the advantages that you've found with it.
Okay, I'm glad you found it useful.
Yeah, and like I said, if anybody has suggestions for future topics, I actually think I'm finally at the end of my backlog of items that I had. I had lots of speakers lined up for a long time there. So, if you have an idea for me, send it my way. Otherwise, I'll come up with something. And yeah, we meet the first Tuesday of every month. So,
well, Brendan, if you can find something that handles CloudFormation, deletion, and recreation with an import of your existing resources, that would be useful.
Yeah, that would be, I would call that talk like CloudFormation pain in the ass, because that's currently my big pain point too, is persistent resources that get generated nicely on the first run of a CloudFormation stack, and then you either run into race conditions or having to store state outside of AWS. Like that's one of the persistent kind of plagues for my use as well.
Yeah, things go wrong and you want to delete and start over, but you don't want to delete data.
Yes, that's exactly it. Is people uploaded data, especially like, processed PHI. So you'd actually have to go back to the client and say, hey, can you re-upload stuff, because we're only storing an aggregation of it. Like really valuable stuff is that's kind of a real problem to even have the possibility of a stack, like delete stack kind of removing. So
yeah, our team might be moving to Terraform, and I know that it has an import feature, so I'd be interested in that too. Brendan, if someone's interested in.
Well, I was actually going to say, Colin's the one who was our Terraform presenter.
I did run a Terraform thing, and my problem with Terraform is a very similar thing of, with Terraform, you have to store the state yourself. So someplace has to store the state, and it's not like a really great solution I've found for it so far.
Yeah, and that's something that, if you look at kind of the whole, infrastructure as code, CI/CD, the whole movement around things, the thing lagging behind has always been data. Like if you look at, if you compare Terraform to something like, Liquibase, for the kind of the database side, or like Chef or Puppet, whatever, the database side of things has always kind of lagged behind, and it's because it's a much harder problem when you have to consider persistence.
You run into your ACID promise, like, and working with Puppet, it's the same way. Is where are you storing your state? And when you ask, so for Puppet, it's Puppet Master. When you ask Puppet Master, like, hey, what's the state of things? And it does some query on the back end, however you have it set up. If you don't get an answer, if you get radio silence, what the hell do you do? And that's usually like the main problem I ran into in like the DevOps realm is, oh heck, what do we do if we don't get an answer? It's not like if you get a bad answer or if you get a good answer. Those are pretty clear, like happy paths of code. It's what if you get no answer? And so what if you go to check the state of a thing and you get nothing? What the hell do you do then? So that's
kind of the same thing as like, even in, microservices and event-driven architectures, it's, if you get a positive response or a negative response, if you get a success or if you get a failure, that's cool. You can code for that pretty easily to be able to handle those scenarios. But it's, what if you get a partial success? What if you might get an answer if you wait a bit longer?
Yeah.
Those are the edge cases that get a little more interesting.
I usually don't deal with partial successes. I on account of like, I just hash the keys. If you don't get all the keys back, it's a fail. And so, but yeah, my problem is if you wait a little bit longer, and then it's like trying to sort out like, oh god damn it, how much longer do I wait? Because in test, like with 3 nodes and I don't know, a couple of terabytes of data, I can approximate my wait time. But in production, there's 2 clusters of 5 petabytes of data separated by 250 miles. So how long do I wait now? And that's always like a really good kind of question to, I'm kind of curious as to how do other people solve these kinds of problems, because the solutions myself and my colleagues came up with feel very much like duct tape and bubble gum.
Yeah, I mean, I was rolling pretty hot and heavy in the Azure world, a little over a year ago. And, that was always one of the problems was, how do you handle these things that need to be persistent, these things that are handled differently? And I think some of the things that, Russ was referring to as stacks and whatever, I haven't really messed with the AWS world that much, but, those are things where I would handle it as, in Azure, you have resource groups that are just like a set of things that would get created, deleted, moved together. And I would, get in the habit of, this thing is different. This thing is persistent. Therefore, it gets a separate resource group, or maybe it's lumped in with some other things, or maybe it's completely on its own. But yeah, you always had to treat it somehow different. And there wasn't anything, at least, natively, where you could say, hey, I want you to delete this thing, but I want you to keep the memory of it so that, if I decide to recreate it at some point in time, down the road, you can recreate it based on that prior state. That would be wonderful if things like that were, built in, where you could just have it automatically do the backup and the restore, where you're saying, yeah, I want to delete the existence of this thing, but I want to keep the state of the thing, the things that were stored in it, whatever the way the bits were at that point in time, keep that, but, take it down so that it can't be accessed until it's recreated, for whatever, benefit you find in that.
You did just kind of describe what they do for RDS. You can have your, forgot the name of the the value you give it. But it's a configuration option to say, if you delete the thing, it will take a final snapshot of it and save it off right before it deletes it. So then
Yeah. You could do that for, I do that for Elastic Storage. I shuffle off my Elastic Storage over to like Glacier. So if I ever, because I'm doing a lot of scientific research, so the data is like super clearly, here's where the data lives. You don't get a bunch of config kind of like mucked up into it, where it's like, here's data that changes frequently, here's data that changes infrequently. Here's a big blob of observations. And when I store that, so I store that using just Elastic Block, because it's very easy to attach that storage. And when that goes for like, as part of the, I actually have a Lambda that writes that off to, well, now it's part of S3, but S3 Glacier, because I don't expect to ever go back to it again. But in the case that the state's bad, sure, you want to look at it again. But I think it hits the nail on the head when Brendan was like, I want to like recreate the functional bits of this, but I want its memory intact. Like, I just want to change how it does the thing, not the state it was in. And so, like, I think that's a general purpose kind of problem, which is also, I think, very difficult to solve, as all of us have our own hand-rolled solutions for it.
But it's nice they give you certain tools, like that ability to set it up so that if you do delete it, it automatically copies it. I mean, that solves part of the problem.
Yeah, it at least tries to help you prevent accidental, apocalyptic failure.
Right. But yeah, Brendan, your heat stacks are very similar to CloudFormation stacks. I mean, the code and everything is very similar.
Oh yeah, resource groups for Azure are analogous, roughly.
Yeah, so by you saying CloudFormation and Heat are very similar, you mean that they can sometimes seem a little, sporadically behavioring. Sometimes they work, sometimes they don't.
No, that's
Sometimes
not what
it
I'm
takes 20
referring
minutes.
to.
Sometimes it takes an hour.
You do have some similar problems, like, race conditions or just, headaches. But I think it's cleaner and easier and better on AWS than on the OpenStack systems you're working with.
Yeah, and I'm sure they've had for one, they have a lot more money behind the problem, a lot more incentive to fix it. But also they've had a lot of opportunity to learn from some of the mistakes of the OpenStack world.
So I've got nothing else, and if anybody else does, we can keep going. But
Well, if we're kind of wrapping up, I'll also throw out there, if you're interested in contributing to open source, we have officially started Preptember, the lead up to Hacktoberfest. So if you're not familiar, if you just Google for Hacktoberfest, DigitalOcean is one of the big sponsors. And what it is if you sign up and you do 5 pull requests to open source projects, you get a t-shirt. I would love to show off mine, but my camera won't work. But yeah, it's a lot of fun. And Lansing Codes, if you're part of the Slack community there, we have a Hacktoberfest channel where people will throw around ideas for different ways to contribute. There's also different projects that you can do for Lansing Codes that would get you those pull requests so you can earn your t-shirt.